Good morning. See, I am now discussing a few more problems in the chapter electric charges and field, and this noted as electric charges and fields number 202. Okay, I go with the first problem. See, in all these problems, I focus on simplification or how simplification can be better or faster or smarter. So, all these things, you should carefully observe and you can apply this in the anywhere more solving problems more and more and faster and faster. Okay, an alpha particle of mass 6.4 into 10 to the power minus 27 kg and a charge. So charge is okay, because of the two alpha particles, two protons, 3.2 into 10 to the power minus 19 coulomb is situated in a uniform electric field of 1.6 into 10 to the power 5 volt per meter. The velocity of the particle at the end of 2 seconds. Okay, because the alpha particle is situated in a field, it experiences an acceleration force and therefore an acceleration. Okay, and because of the acceleration, when it travels a path of 2 into 10 to the power minus 2 meter, when it starts from rest, what would be the velocity at the end of it? That's what you have to calculate. I have a detailed calculation, but how faster we can do, I will just explain now. See, look here, this is the detailed calculation, you can just work out later. See, this is mass of the alpha particle. What is the electric field is this, charge is this. What is the force? Force is 3.2, this is charge, 1.6 into 10 to the power minus 19 and 3.2 into 10 to this is the charge, and okay, this is the electric field. Q into E is the force, so this is Q and E. Okay, Q into E, and say okay, this is the force and you have to calculate the acceleration. Now all these, say the force, supposing you don't write all the powers, you just for the moment you neglect, because see, looking at the options given here, all of them have 10 to the power 5. Okay, all the options have 10 to the power 5. So therefore, supposing I ignore the powers, so then okay, force I can write it as 3.2 force on the alpha particle. Force on this I can write it as 3.2 into 1.6. So if you want the acceleration, this whole divided by mass. The mass is 6.4. I am not writing the powers. So okay, this simplified. See, I simplify it as say 1.6 4 times and 4 cancels with 32. So I write it as 8. See, this is my way of simplification. Okay. So I got 8 meter per second squared, supposing I assume that. So then, see, look here, come to this step. So v squared equal to 2as, velocity equal to square root of 2a into s. 2a is 8, s is 2 into 10 to the power minus 2. I will just write it as 2. So therefore, this is, say 4 root 2. 4 root 2 is nearly, okay, 4 root 2. See, look for the options now. So calculation, see, look here, instead of all of these calculation, I have written only this. Okay, this is what, this saves time, and of course, so therefore 4.2, option D is the correct choice. Okay, this is how simplification can be smarter. Okay, now coming to the next problem. Two identical balls A and B have positive charges Q1 and Q2 respectively. Q1 not equal to Q3. Balls are brought together so that they touch each other and then kept in their original position. The force between them is, see, what will be the force between them? So okay, see, instead of the regular problem, supposing the total charge Q is distributed between the two spheres, one of them is Q, the other is the other is Q minus X, Q minus Q, Q minus Q. And now the force between them will be F equal to K constant, product of the charges, Q into Q minus Q divided by D squared. See, now you have to find out force between them, say, will be greater, or when will be the force maximum. Okay, this problem actually another problem where you have to find out when is force maximum, when this force is maximum. See, that you can find like this: df by dq dx, df by dq is 0. So if you differentiate this, what do you get? Say, how do you differentiate this portion? See, q into if your differential coefficient of the other one is -1, df by dq I am doing. So the other next q minus q into differential coefficient of this q, that is 1, that should be equal to 0. df by dq is 0. Okay, this is actually df by dq. So this should be equal to 0. So if you, what do you get from this? Q equal to 2q, or q equal to q by 2. If the charge is equally divided, so when they touch each other, actually the charges become half of them. Or if it is q1 and q2, q1 plus q2 by 2 will be the charge on each of them. So therefore force will be maximum, greater. If they touch each other, the force will be greater than that before. See, that means it is not less. Okay, it is not same, it is not 0, it is greater. Okay, you should also eliminate the other options after selecting whichever the correct one. Okay, this is how the detailed solution goes. Instead of that, okay, you can solve the other by the shorter method. Okay, now you have got one more problem. Two small spheres of masses m1 and m2 are suspended by weightless insulating strings of length L1 and L2. The spheres carry charges q1 and q2 respectively. The spheres are suspended such that they are in level with one another. So okay, you got one sphere here and the other in the same level. And the threads are inclined with a vertical at an angle theta 1, theta 2 as shown. Which one of the following conditions is essential if theta 1 equal to theta 2? Okay, theta 1 equal to theta 2, then what should be the condition? Okay, so this, to solve problems of this, you must draw the free body diagram. Free body diagram means, so okay, tension is acting, and then weight is acting, force of repulsion between the two. What about this force of repulsion? F1 and F2 they have written here, but are they equal? Unequal. See, F1 is action, F2 is reaction. Therefore, that is force between the two charges. Action and reaction are equal and opposite according to Newton's third law. So therefore, F1 equal to F2. You need not write F1, F2 separately. F1, F and F you can write. Now, you had to see T1 cos theta 1. What should be, that must be equal to, in equilibrium condition, m1g. And okay, T1 sin theta 1, that should be equal to F. Okay, so I have written here, say T1 cos theta 1 mg and T1 sin theta 1 F1. So therefore you get tan theta 1 in terms of F1 and mg like this. If you divide these two relations, you get tan theta 1. So straight away, instead of writing all these, you can write tan theta 2 F2 by mg. F1 equal to mg, if theta 1 should be equal to theta 2, look here, if theta 1 should be equal to theta 2, because F1 and F2 are equal, F1 and F2 are equal, see M1 should be equal to M2. M1 should be equal to M2. So which option? This is the condition. If theta 1 is equal to theta 2, M1 must be equal to M2, option 2. Okay, listen to this next problem. Two identical charged spheres of material density rho suspended from the same point by an inextensible, you should be able to imagine visualize the picture. Okay, say two you got suspended, say one of them like this, the other is like this. So you got two strings and you got two spheres here. Okay, of equal length, make an angle theta between the strings. When suspended in liquid of density sigma, the angle theta remains same. Okay, the dielectric constant of the liquid is, now okay, dielectric constant, it's a number greater than 1, that is one thing. And now see, in air, the what will be the weight will be mg, but m is v rho g. V into rho is mass, that into g. Okay, this is in air. What will be the, supposing the whole thing is immersed in liquid, so then what will be this weight? Weight will be v rho minus sigma, because there is an upthrust. Okay, upthrust on the, there will be an upthrust here. So therefore resulting effective weight will be v into rho minus sigma into g. Okay, see now this theta is same, so therefore, okay, if you equate, so then what happens is you will get the ratio of this. Okay, dielectric constant is the ratio of the forces. Okay, ratio of the forces results into theta is same, so therefore ratio of the weight of the effective weight of the sphere. Okay, effective weight of the sphere, that means you will get rho divided by rho minus sigma. See, look here, one thing is this, if you consider this option, okay, rho minus sigma should be there in the option. Rho minus sigma divided by rho is smaller than 1. Okay, whereas the electric constant is a number greater than 1. Therefore, point number 1, the answer must contain rho minus sigma, and point number 2, it should be greater than 1. Therefore, option A is the correct choice. I have, of course, the detailed working, you know, say instead of writing all these in a CET exam or a competitive exam, say you can select the correct option using the common sense. Okay, it should be ratio and it should be greater than 1. Okay, all these ideas you should be able to apply in several more problems and solve more and more. Okay, we will solve more number of problems in the next video. Thank you.